BSides DC would like to thank all of our sponsors, and a special thank you to all of our speakers, volunteers, and organizers for making 2018 a success.
My name is Omar Farouk. I work for ISC. Today we're going to be talking about how to secure multi-organizational cloud environments. I'll get into what that means a little bit, and then we'll talk about how to actually the strategic and tactical design principles and security principles to secure these environments. Who am I? Like I said, my name is Omar Farouk. I work for ISC. I'm a software and security engineer. We are based out of Baltimore. And generally what we do is we do a lot of white box based assessments. So we are a bunch of engineers who just essentially love to take apart things and then build them back together. We do a lot of some software development work, so I'm also focused on that. Academically, I'm an engineer. I have a master's degree in electrical and a bachelor's in computer, and I'm a PhD candidate at UMBC. ISC is a company that came out of research. We are an AppSec security evaluation company. We work with specifically in multiple verticals, but one of our major verticals that we do work in is media entertainment. We have some Fortune 10 clients that we do a lot of work for. And essentially our primary focus is AppSec, network security. We currently run an ISC CTF contest that's in the other room. We have an ISC lab that publishes CVEs that are for commercial products. So I think in the last month or 2 months, we have published over 100 CVEs regarding commercial NASs and routers and switches. So if you have some time to take a look, to check out our lab and check out our blog, it's online, and we do publish after we have got permission from the authors, from the vendors. So what is this talk is going to be about? One thing right away, I think I should mention, this has nothing to do with blockchain. If you want to talk about blockchain, I just went to a few conferences of blockchain, but I can talk about that too. But what we are going to talk about is what is multi-organization cloud environments? Why are they different from current multi-tenant SaaS environments that everybody's kind of instantiating left and right, and how they differ and why are they needed and where are they being used currently? And then we'll talk about what the challenges are. And then the latter part, the second part of the actual takeaway from this talk is what the strategic security principles you should be thinking about and the actionable tactical security principles that you can go ahead and today implement in your environment. So if you guys are DevOps engineers or security engineers or CTOs or any of that functions that you in your organizations, you can take some of these things and make sure you are running those, and that will help you get secured day one. So, I will start from a little more basic than from the cloud. Essentially, we will start a little bit and build it up and go all the way to what multi-organization is. But essentially, the idea is that we're going away from data centers. There is no essentially, you can launch a multi-million-dollar company these days out of just having web URL links in the cloud, and then it's very powerful. But also from a security perspective, thinking that the idea that you having your own data centers are kind of more secure because they're air gap is kind of like thinking about security from an obfuscation point of view. We think, or at least I personally think, that if that's your reason for having data centers is because you think your data is secure just because it happens to be in an air-gapped network, it doesn't really mean that it's secure. So eventually not everybody, but most of the use cases most industries can go to the cloud, and they should. So this part of this slide is talk about, the elastic part of cloud, the fact that you can render, for one of the examples in this slide that I talk about is rendering or computing very algorithms that are very compute intensive. And so growing data centers or growing data farms is quite expensive, so cloud is the way to go. So then when we get into the next slide is to talk about, I'm building this up about how people are launching SaaS applications. A very simple SaaS application would be single tenant, single app, single database. You have multiple different customers, you might be a startup, or you might be a large company that has running a specific tool as a web app, and then you would just launch it and you push it out to multiple clouds. Now, from DevOps point of view, that is quite easy. You can have one cloud formation script, and you can actually go out and push this thing out to your cloud and very quickly. Now, from a security perspective, you have all kinds of holes because now you're sharing data and have multi-tenancy at the app level and at the data level. I do want to stop and just say one more thing before we go. This talk specifically is completely cloud vendor agnostic. Even though I might use concepts that are specifically to one of the largest vendors, this is not an advocacy or talk for a particular cloud. So every cloud manufacturer or cloud vendor that I know of, at least the top 3, they all have a similar concept. So even if I do end up using a specific technology that is offered by one, there is somebody who probably has similar technology in the other one. So this is not a cloud specific to one vendor. So then people built on all the other extreme is that you have multiple instances for the application and have multiple instances for data. Well, that means that you are now segregating data and app, possibly not networking. You're still sharing the networking component because you might be in the same region, you might be in the same virtual private VPC framework, but you are guaranteeing or you are saying that we're going to have multiple applications and data storages. This provides some intrinsic security that you might you will get out of the box because you're not sharing the same databases or the same storage object stores and stuff like that. But at the end of the day, there's still configurations that need to be done to secure it, but that's another model people go to. Another third model that people kind of follow through also at the same time is having multi-tenant application with the database per tenant, where you have one application instance, but you're using multiple storage stores or you're using multiple databases and stuff like that. And in that instance, essentially, you have authorization and authentication principles on top of your application that allow you to segregate data, segregate access to data, and the data itself lives in a different databases. So all of these are very common routine things that everybody just launches and configures and deploys in their use cases. Now, what we are talking about today is how there's a whole flow of organizations that are going towards sharing clouds. And the idea is that you keep the data in your particular AWS or Microsoft Azure cloud platform. You have a vendor that has basically a set of applications that they run in their containers, in their containerized environments that essentially might be ephemeral. And they basically say that as long as you open up your URL to your storage, or you give us VPC peering or some kind of sharing with our virtual private networks and on non-public cloud, non-public internet, or even on public internet, how we can actually work on your data in place. And so this is exactly what we are trying to talk about, how now that you have multiple actors or multiple organizations involved. One is an organization that offers you the service you have, and then you have a bunch of people who have their data, and then there's partners like people who might be evaluators, people who might be security auditors, people who might be compliance people who are actually doing things like logging and monitoring that also want to get involved. Now, what are the benefits and why would anybody be interested in pursuing an architecture like this? Well, this is a real world example. I'll get to that. One, what happens is now you're not sharing the cost of a full deployment. As the AWS, but as the cloud environment infrastructure grows, the cost get higher and higher. People are looking in a way to have divided costs based on what they own and what they use. So if you're a data owner, you don't need to have compute-intensive instances they have to pay for, and you don't have to bring those services into your cloud. Essentially, what people are doing is they're forcing the actual SaaS services into a cloud or into a platform that's owned by people who built those, and they actually access your data, work on it, process it, and then send it back to your object storage. Now you own the data, you own all the security principles around it. You maintain the VPCs, you maintain the key management, you maintain all the encryption based on your local policies, and they work on in their cloud, on their policies that might be industry regulated or based on your requirements. And then you have people who are small companies that might be consulting or independent shops that don't need to have a cloud. They just need a cloud. They don't need to have a major cloud infrastructure to get in the business. What they could do is they can have a small cloud infrastructure, and then they can share their VPCs to get access on a temporal basis and go and do an evaluation, or go in or run some kind of audit, or run some kind of compliance. So it makes things easy for all partners involved, because it's divided and distributed responsibility, and it also means distributed cost. So how does this look like in real world? So everybody wants to know how would it look. How we have, as an organization, have evaluated a bunch of these environments. I won't mention our clients, but I can mention some of the reference architectures that we have looked at and what did they look like in AWS, right? And then the way they look like it is that one of the ones that we looked at, and if you're a designer, developer, or a firm that looking to deploy SaaS in a way like this, the way they do it is that they actually set up what they call is a base platform cloud OS, bunch of platform software that's running in their EC2 instances or their compute instances, and that's the middle swim lane. Essentially, that is SaaS applications running as containers, and there could be multiple verticals of them running independently. On top of the application, and below the applications is the actual is a platform that might be shared services that get used across multiple SaaS, and then below that is federated identity service. So essentially, you will have to go and pull tokens or some kind of authentication, but either through an end user or end organization. So you don't even, so the SaaS application owners are responsible for launching and maintaining their SaaS, their softwares and their services in the cloud. They're making sure that they're sanitizing data. They're not holding on to any of the cloud, the data from the actual end organizations. On the right-hand side is all the organizations that might be your clients or your customers. So in that case, what you could do is the data sits in their S3 buckets, or there sits in their MongoDB or whatever the data storage format or storage mechanism is. But essentially, they give you access through a URL or endpoint. They come across, they come in, and they access the data, and then the access to the data itself is limited and controlled by the data owner. So essentially, if there are encrypting, for example, data in a S3 storage, data is being stored at a S3 bucket at an object level, then the keys are granted, and then the key accesses can be revoked, and the data actually stays locally and not has to be, and the access is revoked. And the same thing for giving access. So you can grant access by sharing keys and sharing IAM roles to an organization across the world, and then they will do something like process your data, either in many cases that I will talk about might be like a video that you want to get transcoded, or you want to get it watermarked, or you want to have a transaction that to be published to, it might be a transaction in terms of a financial transaction that you want to get it processed. So the data for the actual user information sits in your data stores. It gets processed and gets some kind of involved in some kind of financial transaction, and then gets back put into your database. And on the third side is where I was talking about partner networks. Partner networks being small little companies or companies that are actually do business on a small time limited basis. They come in, they do an audit, they come in and they come in and look at things and then they go away. So it allows everybody to have a cloud infrastructure that is much more manageable, rather than having one organization owning all of that, or having multiple organizations running multiple large networks of infrastructures and having quite a bit of cost. So where have you seen this, and why? What is a good example of this? So one of the good examples is, like, if you think of any kind of productivity software that you might be using today, like any creative software, any editing software for music or videos or multimedia or any of those, they're essentially running this platform. Essentially what's going on is you get an instance of the app itself, but you can actually control the data in your cloud. So if you're a large organization that has 1,000-seat licenses for a software that does graphics, or a software that does mechanical graphic artworks like AutoCAD or whatever, then you essentially could get an instance of their, get access to the data. You would launch the application in their cloud, but the data itself would be living at the back end in your AWS instances. And that would be it would be a good partnership because you are storing the data locally or in your cloud, and then eventually they're just allows you to launch the application and then go away. And a lot of those times, what we have seen, a lot of those vendors are kind of like at least say or promise to be ephemeral, or in a way that they are running into in instances that are supposed to be on per client or per use base. So eventually, when they do come up, they do some level of servicing for your client, for one organization, and then they go ahead and they get released out. So it is also, like we talked about before, it has the concept of using multi-app, but multi-app and multi-database kind of tendency. So essentially, it's the same model, but over a large number of cloud networks. So where else we have seen it? I particularly have seen this examples of this in performance compute, where people are running images or videos or music files or unreleased content and try to get it processed. And for example, if you're like a production house and making a film or something, and you need to get it translated, and there's a translation software that somebody runs, then you just essentially open up your S3 object database, provide them a key, provide them access to on the IAM roles, and then they go and access that file, do this, they run it through this software for whatever they need to do, and then they can put it right back. And that way, you can revoke the keys and remove the IAM user, and essentially the data actually possibly never left your database, your data stores. I already talked about a bunch about why this is really important or why this makes sense, but I think from a larger storytelling point of view, it's important. It's because, one, it divides the cost. Not everybody needs to run huge AWS or Microsoft Azure instances and compute devices and run everything and get it instantiated in a self-hosted environment in AWS. So if you're an organization that likes to run everything self-hosted, you don't need to do that anymore. You can possibly get a VPC sharing or get a subnet or get a VPC that you instantiate in your cloud environment or AWS environment. Share that VPC with the vendor and let them run it, and then you don't have to incur costs of running large EC2 instances. And then, so exactly. So what are the problems that we're trying to solve with this? So one is how do we validate that when the SaaS application or organization says that we don't actually keep any of your data, we actually just process it and sanitize it? How do we verify that? That's one of the issues that come across. From an application cloud point of view, how do we know there's segregation between our processing of one organization's data to another? From a data cloud point of view, how do we know that the data itself is secure while in transit or in use, either at the data cloud point or actually in the SaaS cloud? And from a service partner cloud, how do we know that if an audited company is looking at your data or is looking at your SaaS, how do we know that they're only looking at it as a passively and only looking at it at a limited access point of view? Because there's multiple people involved and multiple different large organizations involved. How do we know that everybody is playing nice with each other? So before we get into it, this is very important. So before we get into it, further down the road about why is this important and all that, the threat modeling aspect is very important, because I have had conversations with a lot of folks, and they're like, oh, the government will never do this, or this will never work. So I think it's very important to take things in context a little bit and understand that this is not a one-all solution for everything. It depends on first of all, it depends on what your driving force is. If your driving force is economics, it makes sense. But if your driving force is your government and your DoD and you don't care about money and you just want to have it won't matter, right? So we definitely want to take a little threat modeling and understand why are we doing this. But if you're a private entity or a commercial entity and you are trying to bring down cost and you are already running into public internet, yes, you need to worry about these things and you can take advantage of them. So usually from a threat model point of view, within the context of if you're driven by economic forces rather than DoD or anything like that, but even in the government, even in most government use cases, you can actually put stuff in the cloud. I mean, I know personally of customers who are working on in spectrum sharing and for health services companies and for agriculture FDA that are using cloud. So it is very applicable in government too, but not to all extent. And so I just want to make sure that people always push back and say, oh, this is not going to work well, it's not applicable there at all. So when we talk about threat and model and trust model, I think it's very important to take a look at understanding what are you protecting as an organization, as a SaaS or as a cloud owner of a data, and what is your biggest threat. So in this particular instance, I want to make sure that we baseline that to say that most of the times that most organizations will be protecting their reputation, they will protecting the data that's proprietary, and then all of that in availability might be important, but most likely it's either reputation or the content. We come from, or at least I come from, a background where we do a lot of work for media entertainment. So a lot of it applies in a way that if you have content or you have assets that are very valuable for a short amount of time, but they're not really very expensive after a certain amount of time. For example, a film that gets released after a certain time, it's not really that important, but before that, it's extremely important. So you have to understand, I think that it's very important to understand what the value of the asset is. And in this particular case, when we talk about sharing cloud in the organization, I think, at least in this conversation, we are framing that as not like super long term, but most of the stuff is very highly valuable for at least short amount of time. So in this part of the talk, I think we will go down to this part of the rest of the conversation is going to be about actual takeaways from strategic principles and actionable tactical things that you can go and write down and apply to your AWS control configurations and build cloud formation scripts out and then deploy them. So first we'll talk about strategically for what you should be driving towards and then how you can implement them with tactical things. So as everybody should, from a cloud perspective, depth and defense is obviously very important, but what does it mean in this particular scenario? It just means that you take everything from IAM to networking to system networking, from IAM, from data security, and then from EC2 or compute aspect. You take all four of them and you layer them. So essentially, you use role-based access authorization, and you use key management to protect data. You actually have hard AMIs for EC2 instances. You have software patch management systems for your software updates for your EC2s, or if you're using container for ECS services, or if you're using services in terms of if you're using Forgate, for example, then you solve all that problem, right? You don't even have to worry about how to actually manage the patch management at all. They're already done for you. And I think one of the things that we do want to talk about, and I will talk about down later in tactical, is a little bit about serverless compute, where if you're a SaaS provider and you are going to be working with someone else's data, it might make sense to be using Lambda functions or functions that are just run in instances that you don't have to worry about. You don't have to worry about management of software. You don't have to worry about management of patches. You don't have to worry about management of the firewalls and the rules of the actual compute instance. So the next principle is least privilege, and I think the way I like to think of it, at least, is how to use least privilege in a way of like a chess, right? So you have chess pieces that have a higher flexibility in terms of movement, but and then you have chess pieces that are more in number, but they have less flexibility in movement. So I know this slide is a little bit more very AWS centric, but it still gets the point across that essentially at the end of the day, if you apply correct privileges through identity management and through key management, you can pretty much lock down any data. And the way you should do it is, for least privileges, is deploy, like, say, multiple planes of control plane and a data plane. So essentially you should be applying a control plane that only allows people to manage the keys, for example, but not use the keys, and then apply a data plane where people can actually use the keys to encrypt or re-encrypt or derive new keys, but they should not be able to delete keys. So the idea of having least privilege could be, is actually implementable through thinking of things in two different planes that are orthogonal to each other. Separation of duties, obviously, either this could be done through roles or it could be done through people. It could be done through, specifically, if you have a large organization, you're like, you have folks to actually, if you have a large enough infrastructure, then yes, you would need more people. But generally, think from a role perspective, push out people that separate out the duties in a way that they overlap, but also they are verifiable. Default by secure by default. So essentially, this is what I was talking about before, right? Serverless compute, or in this particular instance, is like using Fargate or some kind of a configuration. For example, if you are doing any kind of automated deployments, push things out in a secure way. Push things out in the most least flexible, most tie down, and then write exception rules to actually open up specific ports. So for example, a good example of this is like if you are going to be running into multiple VPCs, you are going to have multiple subnets, you're going to have multiple security groups, and all those security groups and all those VPCs and security groups, VPCs, and all the subnets should have policies that should lock down traffic first, and then open up on specific ports or specific source or destination pairs as you go along. So this should be, I think, should be come up first, but automation. So I'm a particular big fan of, like, in Microsoft Azure or in AWS, to use CloudFormation. So this essentially is like an idea that people make mistakes. You are going to make mistakes. You are going to make configuration mistakes, and those mistakes are going to lead to open holes. And it is one of the ways to actually limit or minimize the number of mistakes or open configuration issues you are going to have, is to use things like CloudFormation scripts or things like that automate deployments. So if you are going to be running, you are going to have multiple instances and multiple accounts, try to push out infrastructure deployments rather than doing through hand, set up them as stacks and create those stacks through scripts, and those should be pushed out as one shot. So create as many parallel stacks as you possibly can, and then push those out, and that way you are keeping things in modular form in a component where you can have a stack of ECS instances that do specific service, or you can have an Elastic EC2 service that runs as a platform software, but runs as a stack, and you push it out. And last but not most important, and specifically in this multi-cloud organization, is to, I'm sorry, it shouldn't say automation there, it should say trust with reluctance. But what it means is that log everything. You should have your own logs for at the service level, at the application level, at the host EC2 instance level, or the machine level. You should be forcing things at as much as possible to either refutable evidence of, yes, you are doing what you're supposed to do, and then you can actually validate to say that you sanitized the machine, or you took down a machine after a certain amount of hours when it was supposed to go down because you had done a specific job for a specific client. Or if you're in the data cloud part and you run a data cloud where you have all that, then you should be logging all data uses, all API calls, all the number of people who actually have access piece of data, who have active keys to it, who are actually, how many times people call to that endpoint and things of that nature. So to bring it all together and to bring it into like actual concrete tactical things that you can actually go implement and switch on today. If you go onto your AWS account or if you go into your Microsoft Azure account, we've been talking about a very high level, so we probably could just go down to a point where we can go down to the specifics and talk about those. And then what we're going to do is we're going to talk about, in 4 different sections, we're going to talk about networking and IAM and KMS, and then storage and compute. And those are generally, those are very specific, those are not, I know I have the word S3 there and EFS and EBS, but block storage, file storage, or object storage, whatever your vendor calls it, it's the same thing. So first and foremost, start with your cloud consoles, right? Start with your API keys. Start with who has access to your cloud environments. So you have a bunch of developers, you have integrators, you have testers, you have DevOps, you have architects. So figure out who has the keys, figure out who has access to your cloud environment, and then essentially lock those down, put them behind a Bastion server if you're specifically giving access to host to EC2 instances or however, and monitor log all API calls that are coming from the vendors that you have given keys to, and continuously audit and like assess the cloud resources and components as they get used. Now, one of the things that I think I would like that it's very important, I think it's organization also, where as eventually you are going to have multiple clients and multiple data sets or multiple SaaS services running in parallel, organize them using resource groups. This is like, it's so important to be able to take a certain level of resource groups and just turn it down because you either have an issue or you either are not using it or you have misconfigured it. So it is, as somebody who's setting up to go out into a cloud environment where you are going to have access to multiple different, either as a data cloud, you're going to be opening your data centers to multiple different SaaS services, or SaaS services that are going to be talking to multiple different disjoint clouds for data clouds. It's very important to resource those, to organize those using something like a resource grouping or whatever your vendor calls it. Essentially, the idea is that if you in your console know exactly how you have laid things out and how you have organized them, it's going to help you in the future to either grow them or shrink them, or even just configure them as a one set rather than doing it individually. The next thing is like identity management, like IAMs, and talking about authentication and authorization. So things like force everything through roles, and essentially kind of restrict, like I said before with control and data planes, have an idea of using things like 2FA, using strict passwords, session timeouts, control number of accounts that people have. Look at the last time somebody used their IAM keys. Right, most vendors, when you go in, they will tell you exactly when was the last time somebody pulled a key or somebody made an API call. So write a script that actually just disable accounts after a certain amount of lack of use, or go in there and audit all the users that you have in your IAM, or what federated identity system you are using to allow the API calls to look into who's granting tokens, and if they are being granting tokens based on time of how long they've been logged in, limit number of tokens that somebody can get, or limit the timeline, and then reinforce them to re-authenticate after, like, say, whatever you feel is the right choice for your app, but generally, like, say, like a day or 30 minutes, however the volume of your API access is. Networking. So this is like technically the first layer, right? I mean, you have to, essentially the way all cloud vendors have set up is that limiting traffic based on certain source and destination pairs. So security groups VPC route tables, and the third is the VPC flow logs for Ethernet traffic within the VPCs are very important. So take a look at those and see how they're set up, how often you monitor them. They will tell you who's using your data or who's getting access to your application. Go back and take a look at if you still have a partnership or relationship with certain organization, if you need to have those rules in there. But generally, like we said before, lock everything down in terms of open routing tables and open security groups. And that should be your first layer of defense. Essentially, if you limit the traffic coming in, you will shrink the attack surface quite a bit. So logging and monitoring is the next, the next big thing. So essentially, for example, AWS or Microsoft Azure have CloudTrail and CloudFormation. Essentially, you can either bring in your own SIEM tool and then have it offsite or have it in a different cloud. But having logging applications, logging EC2 instances, or logging at the actual compute resource, or logging at the at VPC logs, logging at the KMS level, logging at the KMS being key management, logging at the block, not the block level, but the object storage level. If you bring all the logs together and aggregate, you can pretty much put together a very comprehensive picture of who is accessing your data, how often they do it, and if they do it in a way that's accordance to how you granted the access. So if you are running into, like if I am the person who owns a bunch of content that they usually go out to, say, for VFX rendering to outside organization, and they have access to my S3 buckets, I would want to set up logs to kind of get a picture of when they pull content from my buckets and when they put it back, how often they are accessing data, and if they are trying to access data that was revoked or the work was completed after a certain time, they shouldn't be doing that. So those should be kind of like, you can put together quite a comprehensive a picture of alarms and faults and unauthorized access through logging and monitoring. So another main concept is the storage, the object and block and file. So if you are using S3 buckets or using EBS or EFS, however, what we like to at least say is that if you're specifically running in a multi-tenancy environment and specifically running with, you're interfacing with multiple vendors who might be accessing your data, then encrypt the data. Not just encrypt the data, but encrypt the data with specific keys that are specific to certain vendors. So if you have a data store that has an object store that has multiple keys and multiple objects in there, and there are for disjoint organizations and multiple organizations are going to come access it, specifically encrypt those objects with specific keys that are given out to those organizations. So in case they try to access a piece of data that in the object store that is not enumerated for them, they still won't be able to decrypt it. Or if you want to revoke the key to a certain organization, you don't have to re-encrypt all the objects in the S3 bucket. You only have to re-encrypt some of the objects because you're only pulling down keys for one organization. So it's the idea of compute. If you're using ECS or containerized services, if you're using serverless compute like Lambda functions and stuff like that. Generally, in multi-organizations kind of thing, what is most important is that if I'm an organization who's giving out access to data, then I would want to make sure that either you sanitize the data after you're done on your EC2 instance, or you tell me that you're running on a certain kind of like Lambda function and then it goes away, and I know that you are not holding a cache copy or a copy of the data in a way that it's kept in storage. So the whole premise of using multiple clouds is that the middle layer, the folks that are actually working on your data for a short amount of time to do certain specific algorithms or functions, they should be kind of like telling you that, hey, we're going to do this in a formal way, possibly in a formal service like a Lambda function, run it through our proprietary algorithms, and you're going to get an output, and we're going to put it back in your S3 bucket. Well, you want to make sure that if they are not using, like, say, natively serverless services like Lambda or anything that just runs for a short amount of time, like a batch function, then you want to make sure that if they are running on a container or they're running on an EC2 instance, that instance itself either gets somehow sanitized based on a policy that you dictate, or it gets, if it doesn't get sanitized, but the instance itself goes away, or if it's a container, that if either the container ownership stays geared towards just one organization. So for example, they can also come back and say that, look, we are going to give you X number of containers for you guys that you are only specific for your organization. So since you need the service to be very real time, for example, we had a client that said, we can't take the service down, because if you take the service down after every transaction, it takes quite a bit of time to bring it back up. Well, then what you could do is you can set up a subnet and have multiple ECS services that are dedicated to one specific destination or route pairs and based on a client. So you can kind of force traffic from one particular organization to just come into that application instance, do a per function, and then go out. So it was an example of, for example, a transcoding service that had to happen. No, not transcoding. It was an example of creating thumbnails on pictures that are created on an editorial service, and that has to happen pretty quickly. So that's as an example where you can't just take the service down, because if you take the service down, it takes quite a bit of time to bring it back up. What you could do is you could, put it in a specific subnet and then limit that traffic to the subnet to a specific user, and then after that organization or your relationship has come to an end, you can actually just take the whole subnet down, all the EC2's instances in there. And that goes back to the idea of organizing resources either per organization or per client or per application you have, and resource tagging them. So all of that is tagged in a way that you can either bring a whole client back up, or you can take the whole client back down in a very verifiable way. And I think one of the last things we want to talk about, and I think I gave a talk last year about this, was the whole idea of key management. This is very important on a data cloud part. When you have when you're running, if you're a large organization and you have all kinds of data and all kinds of vendors that you talk to that have access to your data. Key management is the principal method to actually control access to it in a way that the actual data itself could be limited and revoked in an efficient way. So essentially, if you have an S3 bucket, or even in a relational database, or MongoDB database, or however you have, if you use key management in a way that you assign and encrypt objects or rows or columns in specific databases with certain keys that are tagged and assigned to a specific end customer or end user, that could allow you to essentially take away access when you revoke keys, and it could also allow you to grant access, but it would not interrupt any of the other clients. For example, if you had just taken one key and encrypted the whole database, or if you had taken one key and encrypted all the objects in the S3 database, you would have to re-encrypt, or you would have to if you did have a data breach, or you had some kind of issue where unaccessed or unauthorized access had happened, you would have to re-encrypt all those all the objects. So key management itself, I think it's specifically in the key management part in both Microsoft Azure and AWS is quite advanced, and I personally feel that it allows folks to not only segregate data, but also be able to control data, how it gets used. And on top of that, if you just have different data key managers and key users, if you apply that on top of it as a layer, then you have a very solid base of data control. Obviously, when you have key management, it's always a good idea to either rotate keys, audit all keys, and who's using those keys at all times. And that way, if you put that in your logs and you put it through your, not CloudFront, but if you put it through any kind of like SIEM tool to put together some kind of idea about who accessed keys and who was from what IP address or what the source and destination was, you can possibly, if you had an unauthorized access, you can pretty much limit down to specific endpoints and specific users. So at this point, I had 30 slides, so I still have 5 minutes, but I think that I have pretty much come to the conclusion of my talk, but I will take questions. But go ahead.
So you had a slide with various roles.
Yes.
On there.
Yeah. Here? No. Here?
Right.
Yes.
Exactly. So is it the organization of a SaaS provider?
So it could be a SaaS provider, or it could be actually, so what I'm trying to say is that, look, in this particular talk, there's a SaaS provider, there's people who own the data, and there's people who actually are your service partners. So 3 different entities, right?
What is the role of the application owner?
That's a SaaS provider. That is a SaaS provider.
Okay, so what my personal experience in developing SaaS products has been the application owners are great developers who don't necessarily think about the service, which is all vulnerability, which the security concept has too. The net. It's multifaceted. There's network teams, there's database teams, there's app coding teams, and there's all. Are you saying that the application owners are expected to know all these different facets of both the service coding and the network?
No, I mean, this is from multi-organization point of view, right? So within itself, within application owners, there will be multiple people that are ownership of the database itself, the data tier, the business logic tier, or the deployment tier, or how the DevOps works. So all of that would have, those would be subcategories under application ownership.
So who's the ultimate owner of the service itself?
So this is the point. There's people. So if, for example, let's just say for the sake of example, right? There's a company that provides a service for some kind of algorithm that they own, proprietary algorithm that allows them to process specific data. But they don't want to be in the business of owning the data. They don't want to be in the business of storing the data. So they have a SaaS, they have a web service, and they allow you to pull or push data from an endpoint that is provided by their clients. In that case, they're the application owners.
So when you have a customer that's buying your service and you have all these different chains, right? Who's accountable in this picture?
You're accountable for your piece, but you can expect the other person. So all the tactical and the strategic things that I've laid out here are applicable to every member of this, all 3 parts: the data owners and the application owners and the service providers. But all of them, everybody's implementing these controls at their point. In their particular subset, they will be able to build a verifiable, irrefutable set of artifacts to if those are. So, for example, if you detect that you had unauthorized access to your data, right? Either you can yourself figure that out because you're implementing these controls, or you can ask your partner, your SaaS application owner, that what they observed because they were implementing these controls. Well, if you know that, for example, that you are getting an IP address, you are getting access at a certain your endpoint that you opened up for certain reason, and you detect that it was, for example, the key was revoked 10 days ago, but you're still getting access on that URL. What you can do is you can ask your SaaS provider and say, look, we have this particular log, right? What does your log say? Why are you going out and making API calls on our endpoint that we have talked about and revoke keys? So if you implement these set of controls at all levels, then you build this, set of who's you?
application/service owners have their control, providers have their control. There's not exactly, how does governance look like in this?
So the governance happens at your local, so that's exactly, so rather than having governance, so for one, traditionally, if you went and bought a SaaS product, you bought a subscription to a SaaS product, for example, right? You pay somebody X amount of money per user or per X amount of processing, right? You don't get to control the governance. They do, right? But what happens now is you're controlling the governance of your own data. They're controlling the governance of how they process the data. And if you agree with it, then you should go with this service. And if they implement these controls, then you know they're in pretty good shape and form to actually work with you.
I think this is a big conversation.
Okay. So, any other questions or?
In your experience, what's the best way to make sure that your SaaS business partner is enforcing some of these elements? Because I mean, a lot of times with a SaaS, you're kind of limited to whatever is SLA is standardized.
Right. Right.
So, I mean, if you're the consumer and you're trying to implement kind of a multi-cloud environment, what's the best way to ensure that all these items are included in what you're doing?
So I'm not sure about consumer, but like say you're a partner, right? Say you have a business relationship, right? So what we have seen, for example, is that if you have enough leverage, right, you can enforce them to get an audit. You can enforce them to get an assessment, right? But SLAs are more like 999 numbers, right? They're basically about availability. We're talking more about data security. Unless they go through an evaluation or they go through some kind of real audit, not just an automated tool, there's really no way to actually see how they actually implemented all the mechanics underneath in the infrastructure fabric. So and specifically from a consumer point of view, it's very difficult. They won't give you that data, but if you are an organization that are about to invest, say, about a big amount of money with a certain organization, you could ask them to show them an audit data. You can ask them to get an evaluation. In my particular experience, the way it works is that any organization that has any kind of SaaS product that adds value to somebody else, they want your business. If they want your business, they will get an assessment if you're big enough. If you have enough, if you're promising them enough business in the future, they will go out and spend X amount of money to get an audit or get an evaluation. But it's not publicly available. Nobody's going to go out and put an architecture of their service online and say, hey, look, we do it this way. I mean, it's very hard nobody wants to expose that data, but I guess from a perspective, if you really wanted to find that out, there's ways to do that too. If you were savvy enough to know that if certain SaaS is deployed in AWS and you have either understanding of how that works, you could try to backtrack and figure it out, but that's not your responsibility. They should be either be telling you that, or if they're not, then it's up to you to do business with them or not.
I think the problem is kind of enforcing its accountability, just because it's the reason to be named. I mean, not necessarily that. I mean, it's the risk-based decision, right? You're looking at your data, you kind of figure out, can you accept that risk? You're going to say, you lose data, is it exposed? How is it going to really hurt you? How can you mitigate that? So, but I think it's kind of interesting because, I mean, in terms of like saying having a provider go through audit, if it's like maybe a smaller company, maybe. Right. You're going to go to like a sales force and say like, we want you to audit. You better have a really big organization.
Well, yeah, but I mean, but I think that if what you could do is say like you work for say, let's not put like a sales force, but like a large organization that does something with your data, right? And you have all your CRM data in your data stores in S3 buckets, right? And then you want to work with them, and then they want to pull data. Then if you're auditing yourself to certain standards that are pushed out here, then you know that if they are actually not enforcing good security, you will actually catch it because you will have logs on your end that should indicate to you that if you have unauthorized access or you have a data breach. So for example, even if you work with a large vendor like Salesforce, right? And you open up your data stores to them, But if you follow like the key management principles and you follow the IAM principles and you follow the logging and monitoring principles, it should be quite, it shouldn't be difficult to say, why are they pulling our data at a certain volume, or why are they pulling a certain data at a certain time, in a certain region? So all those questions could be answered. And you might have given them access, or if you haven't, then you can actually have a conversation, because now you have an audit trail of yourself that you can use to hold them accountable. Does that make sense? Any other questions? Okay, I've been told to cut it off.